Who remembers what a central angle is? Very good. Okay, an angle where the vertex is at the center. So an angle with its vertex at the center of the circle. Okay, and how do we name a circle? Find what? The center point. But yes, so like if I had this, the name would be circle A. Okay, and so your central angle comes with the vertex at the center of the circle. So that would be an example of what that looks like. Just like we talked about last time, there's 360 degrees inside of a circle, so the sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. Okay, so all of your central angles need to add up to 360 degrees, just like all of your arc measures need to add up to 360 degrees. Okay, so for example 1, it says name the following. What is the central angle? Angle LEY. Oops. Oh my gosh, just rewrite. Okay, make sure you're using 3 points to name our angle. Okay, it's not just angle E. 3 points to name our angle. What are our two arcs? Do we have two majors, a major minor, two minors? What do we have?
A major minor.
A major and a minor. So how do we name a minor arc?
2 points.
2 letters. So which one's our minor arc?
Arc
LY. A lot of you lost points on your skills checks because you didn't have proper notation. Anytime you didn't have that arc symbol, it was wrong. Okay, LY is a segment. Okay, unless you put notation with it. Okay, what is the name of our major arc? Arc LUY. So for your major arcs, you need 3 points and then your arc symbol. Okay, so to revisit our definitions, a minor arc is what? Very good. An arc with a measure less than 180 degrees. And it is named by 2 endpoints. Okay, major arc is what? Very good. An arc with a measure greater than 180, but less than 360. Okay, and how's it named? Very good. So, okay, and real quick, I want to address the idea of the semicircle that we did last time. Somebody in the following class the next day brought up a good point that if you name a semicircle just by the diameter, which is what we discussed last time, I think it was diameter DE, it doesn't necessarily give you a very good idea of whether you're referring to that top half or the bottom half. I do know that those two are congruent, like the arc measure is congruent, the size, the area, all of it. However, to give it more, like a more specific name when referring to whether it's the top half or the bottom half, we are going to go ahead and name semicircles with 3 points. Okay, so you're going to name it just like your major arc. That way, we know which arc or which semicircle you are referring to. Okay, so you could be referring to semicircle with an arc of DAE or with an arc of DFE. Okay, so or EFD if you're going the other way. But we are going to use 3 points so that we can be more specific when naming the semicircle. So use 3 points to name semicircle.
So it's just saying diameter DE, we're going to say arc.
You're going to name it like a major arc.
Okay.
Okay, so when we refer to semicircles so that we can name the specific half that we're referring to, we're going to name it like a major arc with 3 points. Okay. Example 2, we discussed some of this last time, and I kind of told you this is a good foreshadow into what was to come. But what is the measure of angle PCM? 110 degrees. Okay, so what does that make the measure of arc PM? 110 degrees. Okay, so your central angle is the same measure as the minor arc that it creates. Okay, what would that leave PNM to equal? 250 degrees. So what kind of arc is PM? Minor. And how do you know?
Because it's only divided by 2 points.
Less than 180 degrees. But yes, it's also labeled by 2 points. Questions on central angles and the minor arcs? Okay. In example 3, the measure of angle AEN is 18 degrees. JN is a diameter, and JES is 90 degrees. Find each measure. What is the measure of arc AN? 18. Why is it 18? Very good. That central angle is 18 degrees, which makes that minor arc also 18 degrees. What would be the measure of arc JA? JA.
Isn't it supposed to be the other way?
Yes, I lied. Different color. Redo. JA. Blue highlighter is what we're talking about. And it would be what? 162. Why is it 162 degrees?
180 because the diameter is cutting the circle.
Very good. Subtract 18 from 180 because JAN creates a semicircle. Why is it not how I drew it the first time?
Because it's a minor arc.
Very good, because it's a minor arc because it's only named with 2 points, and what I drew was a major arc. Okay, so that is a common mistake that maybe somebody in here would make, because you can see how simple it is. Just make sure that you know, again, that 2 points is a minor arc, 3 points is a major arc. Okay, I'll get a different color since I've messed up now. JAS. So JAS, all of this. 270 degrees, why?
Because it's 360 degrees and part of it is 90.
Very good. So you have one half of this being 180 degrees, and then you have 90 degrees because of the central angle right here. Okay, so 90 and 180 equals 270. Questions on example 3? Okay. Example 4, find the measure of each of the following. The angle of AOB. Okay, right now we have all of the what?
The arc.
The arcs. And what do you know the arcs need to equal? 360. So how can we figure that out? Add them all up and set them equal to 360. So you have 3x plus 15 plus x plus 4x plus 2x plus 15 equals 360. So how many x's is that? 10x plus what? 30 equals 360. So what does x equal? Alright. So now I'm going to substitute in for all my arcs. Okay, so I know this is 33 degrees. What's 4 times 33? 132. What's 2 times 33 plus 15? What is it? 81. And 3 times 33 plus 15? Okay, so what's the measure of AOB? 33, because it's the same measure as the minor arc. What about BOC? 132. COD? 81. And AOD? Questions on a style of problem like that? Okay, 2 more definitions that we went over last time. Let's see what we remember. What is an inscribed angle? Created by what? 2 what? Chords. So an angle with its vertex on the circle and whose sides contain chords. Okay, does anybody remember what the intercepted arc is? Pretty much. Just when you have the inscribed angle, obviously there's not any in that picture, but okay, here's our 2 chords making up our inscribed angle. Okay, so now we are intercepting these arcs, okay? So an intercepted arc is a portion of the circumference of the circle located on the interior, oops, can't spell, of the angle whose endpoint lie on the side of an angle. Okay, so this would be the intercepted arc. Questions? Okay, let's apply that idea then. Okay, number 5 says name all of the inscribed angles and their corresponding intercepted arcs below. Okay, so somebody give me one inscribed angle. Angle DOG, so which intercepted arc goes with it? DG. So you have this angle goes with this arc. Somebody give me another one. OGD goes with arc DO. And the last one. We'll go ODG. goes with
OG.
OG. Questions on the intercepted arc? No. Okay. So, we talked about this as well last time. If an angle is inscribed in a circle, then the measure of the angle is half the measure of the intercepted arc. Okay, so that was a definition that we learned last time. So given that the measure of BC equals 100 degrees, find the value of x in circle O. Oh goodness. If BC is 100 degrees, what is the measure of arc BA? What would be the measure of arc BA? 80. Why 80? Because it's a semicircle. It makes up half your circle, should be 180 degrees. Please get off your phones and pay attention. Okay, so if arc AB is 80 degrees, what does that leave your inscribed angle to equal? 40. Because it's on the half of your diameter. So you notice CA is your diameter because it's a chord going through the center. So that's half. That's half.
Why isn't it 80?
Because it's half the measure of the intercepted arc. You're thinking of a central angle. Intercepted arc always no. Okay, remember what I said at the beginning? I'm not going to talk over you. I literally don't have the voice to do that.
It being a semicircle just gave us the value of that one side.
That one arc, yes. Any other questions? Okay. Theorem, if two inscribed angles of a circle or congruent circles intercept congruent arcs, or the same arc, then the angles are congruent. And we are going to see that in action. Okay, turn it over in example 7. Okay, in circle Q, the measure of arc ST is 68 degrees. Okay, find the measure of angle 1 and angle 2. What they were saying is that, notice that this is an inscribed angle right here, correct? And it's opening up to this arc. Okay, but angle 1 is also an inscribed angle, and it opens up to arc ST as well. So what do you know about angle 1 and angle 2?
Equal.
They're congruent because they open up to the same arc. So if that arc is 68 degrees, what are each of those angles?
34.
34. Okay, so if the inscribed angle opens up to the same intercepted arc, then the angles have to be congruent. Okay, so if two angles open up to the same intercepted arc, then they have to be congruent. Find the example of angle 8. Or sorry, not find the example. Find the value of x in example 8. Okay, so we have another inscribed angle. What is the intercepted arc? Because it's arc FHB or FHG. Very good. So if this arc is 180 degrees, what does that make x? 90.
What's the value of x always half of intercepted.
Intercepted arc.
Sorry, intercepted arc.
If you have questions, you need to ask. Okay, then we're going to move on. Example 9. In circle A, the measure of angle 1 is 6x plus 11. Measure of angle 2 is 9x plus 19. 3 is 4y minus 25. Angle 4 is 3y minus 9. And you know that PQ arc is congruent to the arc RS. So what does that tell you about angles 3 and 4? They're congruent. Okay, because if they open up to congruent arcs, then those two angles have to be congruent. Okay, so how can we solve for y? What did you say? Set 3 and 4 equal to each other. So 3y minus 9 equals 4y minus 25. Y equals 16. Okay, so what is the measure of angle 4? 39 degrees. And that makes angle 3 what? 39 degrees.
I thought it was 6, not 16. Sorry.
Okay, how are we going to figure out x values? 6x plus 11 plus 9x plus 19. Why are those two?
Just kidding. I saw what you were thinking there. It's wrong. Oh, wait.
What is the measure of angle T? Unknown. Why is it 90?
It's 90 because 180 divided by 2.
180 divided by 2. It's an inscribed angle.
Wow.
And it opens up to this semicircle.
Wow.
Okay, sorry, I didn't hear you.
Okay, so what does angle 1 plus angle 2 have to equal what? 90. Guys. It's a triangle. 1, 2, and 90. If this is 90, 90 minus 180.
Oh.
Or 180 minus 90. Okay, so I have 15x plus 30 equals 90. 15x equals 60. So what does x equal? 4. So, somebody calculate the measure of angle 1 and 2. No, they got different measures. Okay, our next theorem is if it's a quadrilateral inscribed in a circle, then its angles are supplementary. What does it mean to be inscribed? Inside the circle. Okay, so if a quadrilateral is inside a circle, opposite angles are supplementary. Okay, so if the measure of angle T is 95 degrees, the measure of angle S is 100 degrees. Arc TR is 160 degrees.
Which way does it go?
Because it has to be less than.
It has to be less than 180 because it's a minor arc. QS is 170 degrees, so how should that be labeled? Oh, it's labeled right. Never mind. I was thinking something else. But on the bottom. And that has a measure of, what is it, 170? Okay, so now we need to find measure of angle Q and angle R. So what is the measure of arc TS, this little part, the overlapping piece?
Could you do it using like the inscribed angle thing?
Could you use it doing what?
This seems very complicated.
Miranda, what did you want to do?
So, like QRS.
QRS, yes.
Hold on, wait, gotta get my brain wrapped around this. Okay, got it.
If you're looking at angle
QRS.
Q, this is angle Q,
Okay, yeah.
which
Okay.
is this
Opens up to
arc.
that side, yeah.
Oh.
And what is the measure of that arc?
We wrote 160.
So what would be the measure of Q? 80.
That's what I was talking
But
about.
can you
Yeah.
do the other thing, like,
Inscribed angle.
Yes.
Because here they said something
Yeah.
like, so we could have just not even done all of that.
Right.
Just been like, done in like 5 seconds.
Right.
Oh.
Because opposite angles are supplementary. Okay, however, listen. Okay, you can use information they gave you for inscribed angles. And you get that piece. And you would get 85. But, like Monica and that table over there were saying, that theorem that we just looked at on the other side, if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. So, if this is 95, this has to be 85 in order for those opposite angles to be supplementary. This is 100, this one has to be 80. Okay, so you're just looking at more than one avenue to solve a problem. Okay, last two. 11, find the value of the inscribed angle. Which angle is inscribed, first of all?
XZY.
XZY. And what is the measure?
45.
Why is it 45? If this is 90, that means this angle is 90. And so therefore it's divided by 2. What's wrong? Okay. Find the value of x. Okay, if this is 3x minus 3 and that's 120, what do you know the measure of 3x minus 3 needs to be equal to? 60. So
when the angle opens up to the circle, it's half, like,
the central angle is the same measure of the minor arc. The inscribed angle is the minor arc.
So if it's on the vertex, it's the same for both.
If it's on the center, it's the same for both.
Yeah, the circle, but
If it lies on the circle, it's half. Okay, so you have 3x equals 63, so what does x equal? 21.